Hello, YouTubers. I burned it up. Or rather, it burned itself up. Because everything else is fine except for the made in China under engineering. These are thermal NTCs. And the reason they do this, people, is because they're underrated. Made in China. I paid top dollar for a 60 volt, 20 amp power supply. This thing was over $100. And then come to find out that I was only running it at 48 volt. Not 60, 48. So it should have been able to do 15 amp. That's all I wanted it to do, 15 amp constant. And just a second. I got bread toasting. I'm hungry. Hello, people. Got my parts in actually yesterday. I've already got one and soldered in. I just got eager to turn the soldering iron on and got to work. I was like, oh, I was gonna make a video on this. Anyway, that might be soldered good enough. Might not be. I think it is. But yep, maybe not. That's what I thought. Didn't think it looked right. These act as a buffer on power surge. They're actually current limiting to a certain point. All they do is act as a cushion. And that keeps the heavy surges down to a limit at first when you go to first connect something up. So that's one. I don't know what they put in it. They were burnt beyond reading. If you guys hear sizzling in the background, I'm hungry. Cooking sausage. Okay, now for the other one. There is a size difference in these. Each one of these is 12 amp rated a piece. So as you can see, there's a size difference there. So they're running in parallel. So that's going to be 24 amp. I don't know what China decided to use, but I really wanted to get a 30, but with a 3-run stretch and not knowing what these are and not knowing what this circuit actually wants on constant power, well, I'm taking a guess at it. I had a power supply a few years back that was rated at 50 amp, and this thing part blew out. Well, it basically just fried itself because it got too hot. I ended up putting a 30 amp in it for a 50 amp power supply. This is only rated at 20 amp, 60 volt. That's what it's supposed to be rated. It can do 15. If the thermistors would hold themselves together, it'll do 15. But thermal runaway tends to cause a problem. I'm gonna have to get in here and do something. There is no direction specific. Oh, come on, stay tacked. The biggest thing to help keep them cool is the airflow that goes through the fan. Blows air this way with the cover on. That airflow, where's the top cover, needs to at least hit the top of these to help cool them off. But with those little ones in there, well, not so much. Okay, that's good. That'll let some air flow through, at least on one, maybe the front side of the other. A lot of times with this stuff, it's trial and error. I could put an amp meter on here to see how much current flows through at, say, 17 amp, and then match a thermistor for that. But these are $8 for two, and they're still a little expensive. But if it gets it working again, which most likely it will, I'm good with that. I need a plug to test the output voltage. What did I do with the plug? Let's back you up. That looks fuzzy. Oh. Okay, let's see if my meter is junk and shows me 0 volts. Ah, 48 volts. Okay, that scale is reading 38. What the? There we go, 48.3. This meter is junk. The dial is just giving up. Sometimes it won't read nothing at all, and I smack the crap out of the dial, and it wakes it up. It's like, oh, okay, well, here you go. 48.4 volts. Pretty safe to say this thing is working again. The only way to really test it is to charge something. But that's going to have to come at another time because I'm hungry. Catch you in a minute. Today we are going to test this. And I'm definitely going to use it to see if it smokes or if it just keeps going. The battery's at 80 volts in the bike. That's typically what I use this thing for. And I think I might have forgot to put it together. Gotta have the cover for the wind tunnel effect. And well, they just don't want to comply. Okay, there it is. Now it's locked in. I'm not going to put any screws in it. I guess I could do one. Wouldn't hurt nothing. Just one of them. It's not exactly one of them, but they should be on my table. What's this thing at? 48 volts? 10 times 4.2 is too much for me to calculate. If anybody's wondering how my hybrid battery is doing, this is day 5 and it's absolutely fantastic. The charging system's keeping the batteries around 3.1 to 3.3 volts per cell. That's absolutely fantastic. Quite pleased. I have seen the voltage top end brake regeneration hit 388 volts. That's not much over what the battery pack can handle. Well, take that back. 365 is max, but that 388, it's getting shut down by the top end chargers. Not too concerned about it because brake regeneration usually don't last very long. That's just a burst charge going into the batteries. But 365 is the top end voltage, and I've not seen it over 3.4 at the absolute most. 100 cells in the battery, that's 340 volts, so it's fine. I don't care about the big surge going in. Okay, let's see. Back to what I was saying. 10 times 4.2. 42 volts. That's 48. That's not going to work. Okay. Need to charge my mower battery. I've got a Ryobi self-driven, and I built a 10S battery for it. I need a meter. I have to steal one. Alright, I'm back. Let's see, I need to charge this battery. That is one of the home batteries. Battery I built from my Ryobi mower. And of course it's, yeah. Plug this in. Oh, gotta plug my power supply in. Okay, whoa. Meter. Oh, 65 volts. Y'all see that? Dust. Let's see. 42 volts. Screwdriver. Make sure it's right. Right on the money, according to my meter. Alright. Plug it up, time to charge. Well, that's certainly low current. 0.21 amp. Yeah, that's not going to cut it. Alright, off to the input. I've got to use a boost converter to charge this battery. They are rated entirely different. You need to test and see if I can get this in the camera here. Using this. These are supposed to be rated at 10 amp, but they're good for a solid 8. It's the bigger one, not the small one. to 42 volts. Yes. .34 amp. Crank it up. There's 3, 4, 5, 6. That's good enough. That's 2 amp per cell. It's a 3P pack. Okay, time to take the power supply out and give it a whirl and see if it smokes. And I'm going to let the camera focus on it so you guys can see if it smokes or not. And if it does, you can laugh at me because, well, I didn't fix it right. But it's entirely up to how much current is going through them thermistors. If it exceeds it, then of course it's going to be a problem. 6.19. Right now it's the input at 25 volts. That's at the input. Now if you guys really want to see what's up, these are supposed to be measured by the input only, not the output, because the output is always different. And let me show you why. Let's see. Plug this back in the power supply. Meter to output and meter to battery. There's an efficiency loss. So that's why they're rated at the input. A lot of people don't understand that, and they crank these things up on the output side to try and match whatever it's supposed to be recommended for, and then they blow. The efficiency loss is well, it's about 20% loss here, roughly. I mean, if you want to do the math, go ahead and correct me. No big deal. I'm just taking a stab. The higher the input voltage matching what you're charging, the higher efficiency you're going to have. But you've also got a limit on the input for these boards. I forgot what this one is. I do know on the big one for my bike, it's 60 volt for max input. That's why the power supply is rated at 60 volt, and it's supposed to do 20 amp, but it's more like 10 because China under-engineered it. Alright, time to pause and go out to the building and give that thing a whirl and see if it sinks or swims. I think it'll swim, but we'll find out. Oh, and just in case you're curious, I destroyed a Ryobi battery and found the input pin to go to here, here, and here. So all I do is slide this in the mower and then plug it up. You need power? Plug it up. That's the way it goes. Need power? Just plug it up. Anyway, off to the building. Oh, and one other thing. If you guys want... Where's the camera at? There it is. If you guys want to use these, find you an old processor heatsink or something to put on it. And if it's got a fan, well, you can't go over 12 volts for the fan. But these heatsink processors, the processor heatsinks, they work pretty well. And this board is perfectly flat, so it's perfect to mount on any type of flat heatsink, but it definitely needs it. Especially when you get up in the top end close to 10 amp. They will get hot. And right now that's just warm. You can tell it, but it's not burn you warm. Anyway, off to the building. Once again, 77 volts. That's going to push that charger pretty hard. Okay, let's see. Do something. Well, I thought I came in with it. What I do? Just grab the keys and camera? Oh, jeez. And I thought I got it. Oh, I did get it. Oh, extension cord. As I was saying before, this building is on my solar setup for home. And this thing pulls some power. I gotta hit the seat there so I can see the meter. And show the meter to you guys so you can see how I've got it set up. Anybody wants to say that thing's loud, you're absolutely right. Loud. Totally. That is a noisy fan, but it's needed. Can I get you to sit here? Can you play nice? Nope? Okay. Alright, anyway. Meter here. This is hooked up to the input, just like I always do. I have a cable running out here, and it always sparks when I put that together. I may end up doing something later to help prevent that, but for now, let it spark. Okay. Well, I want the surge protection on the power supply. I love when it does that. I'll be back. It takes a couple of minutes for it to start working after it trips the surge protection. Internal. Oh, nice. 19 amp. Let's see if it smokes, folks. Oh, 20 amp. Yeah, that's pushing it just a little hard. And I don't have a screwdriver in here to back that down to 17, because I know they'll run 24/7, 7 days a week. I mean, yeah, 24/7. I just focused on it. About tire. There it is. You guys can see it smoke if it does. But here's what it's doing. Can you freeze frame that and see? Because it looks kind of blurry to me. Focus. $13 on the input. Voltage was 77, now it's 78, so it is charging. Now, any of you people that have watched my videos on this, you do not have to use that generic charger that's 1 amp, especially if you've upgraded the battery. What you actually need is maximum cell charge. So 1 to 2 amp per cell is ideal. This battery in this thing is 16P, so 2 amp per cell will give it a fast charge. 13 amp for the entire battery pack, that's very little, so it takes quite a while for it to charge. I need to get a screwdriver to turn that up to 17 right there. Okay, I'm back. I think I'm actually just going to put it at 15 because if the battery voltage is down in the upper 60s or lower 70s, that current will be up. Can't really explain why I did 20 amp there for a few seconds, or for at least a minute. But okay, whatever. I'm with that. 15.25. And it hasn't smoked or turned off from overheat yet. That's amazing. It is warm. Right where those themistors are. Biggest problem, I was wrong about the airflow. It goes in this way and comes out here, But you got the transformer here and all these fins that blocks the airflow on the thermistors. There's hardly any air going across those at all. I mean, I can feel airflow, yes, but it's just really not that strong for as loud as the fan is. And the fact that they're sticking up a little higher, well, that's even better chance of getting them in the airflow to cool them off. So I think this thing will be okay. But if it blows, I'll let you guys know. Catch you later, and thanks for watching.